Alright, so this is the Mastercam interface. First thing you'll notice on mine versus what you're probably going to have open is the color changes. I do have a YouTube video on how to change your defaults as far as your background colors and font colors and line colors, things like that. So you can check that out if you want. It makes no difference. It just, doesn't really affect how the software works. It just has to do with your preference. Next thing you're going to notice is my gnomon in the center. I have a center gnomon here on. And I want to point out that in the View tab, that to turn that on or off is here. So make sure that the gnomon is on. And the gnomon is just one of the planes. It's a 0, 0 for us to reference. The other thing I want to point out is I'm going to be working with some of these managers down here. And if for whatever reason you lose one, they are turned on or off. The visibility of them is in the View tab as well. The rest of these we'll go over as we need them. I think it's the best way to learn this. The other option I wanted to talk about here is File New, File Open, Merge, Save is all up in this File menu. Alright, so let's take a look at our first drawing, which is this one, and let's do a wireframe of this rectangle, extrude it a 1/2 inch thick to make our initial solid part. So we'll get back into here, and our first step is make sure you're in 2D down here. That'll only allow you to draw on the construction plane, okay? So it'll only draw flat. It will not draw 3D in space because the software is 3D. I'm holding down the middle mouse button right now, and that'll rotate around. I can right click, and I'm going to go to top view to bring it back. So now we'll get into wireframe. This is drawing all 2D geometry. We're going to draw a rectangle. I'm going to anchor a corner of the rectangle to the center of this gnomon and bring it out and click once, left click. I will then create the width at 3 inches and the height at 2 inches. Again, make sure this is set to 2D and hit green check. So now we have our rectangle. It's flat. If I go to front view, right click front, it's flat. So let's check the size of this. So one thing I do want to point out, here's some drafting. This is just, it is what it is. It just tells you the sizes. It's not like Smart Dimension or other softwares. It's 2 by 3. Okay? Okay, that's a good reference. Let's window these or click on them, hit delete with the keyboard. So now they're gone. And let's go into levels now. And what levels are is it's geometry organization. What's visible, what's not, how to select this, how to select that, and you'll see how this sort of flows. Right now we have 4 lines, 4 entities on level 1. I'm going to name this part wireframe. Okay? And now what I'm going to do is create a new level by hitting this plus sign. And I'm going to name this model. Okay? Now, it is very important to know that if I right click and make sure this is active, it's the little green checkbox next to the number. When it's active, what you create is going to be on that level. Now, if you mess that up, there's ways to fix it, so don't panic. So now we have our rectangle. We want to go to solids, go to extrude, select, this is the chaining dialog box, will be useless when we get to toolpaths, but just by default, it's going to go to chain it, select the outside boundary, hit green check, and you'll see we're extruding. We're going to change the direction. We're going to create it as 1/2 inch. And that should be good there. I'm holding middle mouse button down and moving around. I will now hit green check. And you'll see we have one piece of geometry, one entity on the model one. And we could turn it on or off, or turn our wireframe on or off. And that's the power of levels. It helps you stay real clean on what's going on. So now, what I want to do is I want to change what level this solid is on. Just to show you, if you click on a solid, right click, and go to Analyze Entity Properties, you can go down to this dialog box here, and let's say I want to create a new level, put it on level 3, and hit green check. Now, that geometry is on level 3. Let's say I didn't want to do that. Right click, Analyze Entity Properties, put it back on level 2, hit green check. Now we're back to the way we were. So you can fix it. Okay? So, we'll pause there. I'll have you catch up, and we'll come back and start creating some holes. Alright, so let's put some holes in this. First hole we're going to do is this 3/8/16 tapped hole here. So let's draw some geometry, some wireframe geometry to locate this hole. So we could go back and make this level 1 active for part wireframe. That's fine. We could do a new level, whatever you want. Let's stick with this level here for now. Or we can change it. So this is part wireframe. This could be part boundary. Okay. And then we could add a new level, and this could be 3/8 16 hole. So now this is active. Notice the check marks next to the number 4 level. And we need some wireframe geometry right now. Let's do it this way. Let's do a little bit of offsetting. So we can offset these lines, okay, a distance of 938 thousandths and 531 thousandths to get an intersection. So what we need to do is go to the Offset tab in Wireframe, Offset Entity, type in 0.938, click this line, and then click the direction you want, then hit Apply, then hit 0.531, select this upper line and click down to pick a direction, then hit green check. So now those two lines are geometry, okay? And if this line remains like magenta colored, that means it was the last thing you changed. So right click and go to Clear Colors, which is the 1, 2, 3, 4th icon on the right in the right click menu. So click that, everything turns to the wireframe color that was either defaulted or you selected. And now we have an intersection. Okay, so now we can go into solids, we can go to hole, and we can select the hole location. So, you know, when we get into modeling, I usually skip a lot of the modeling in Mastercam because most of the time you're going to be importing models. So I do give a lot, you know, a lot of the basics of models, how to do some of the stuff. But most of these skills later on you're going to work with are going to be editing. So I'm not worried about naming this or, you know, necessarily the target. It's going to default most of the time for this. What I am worried about now is the position of that hole. We're going to select this auto cursor position and hover over the intersection till you get the X and click. Then hit enter. So now we have a hole. Now the hole specs are coming from here. If we get into here, okay, you have different options for types of holes. Okay, we're just doing a simple hole. Then you have options for templates too on top here, and this can be, you know, number drills, tap drills, which we're going to use, things like that. And this is sort of the standard area to do holes. You don't have to do it this way. We'll do other ways in a minute where you just create a circle of some known size and extrude it. But for this example, we use this tool here. So we'll go to Filter, and we'll end up going to Tap Drills. And this is 5/16 18, so this would be, should be UNC. And we have 5/16. So let's see what we have here. Or it's 3/8/16. Let me double check that. It is 3/8/16. My mistake. So let's get into here. It should be 3/8/16. That's correct. It does have the correct tap drill diameter for a class 2, which is 5/16. This is going to be through all, so the depth is sort of relevant. Now there is options for a top chamfer. I'll look at the drawing, and there is no spec on that. So we're going to, now again, it's going to default to 90. That is pretty typical to the machinist handbook. We're going to go with 82 degrees. And we'll leave it at that at the 425. That's fine for this. I went with 82 only because we have a lot of 82 degree countersinks in the shop. We stock those. So that's the only reason I went with 82. That is not to the book. That is not standard. It will work in this example, but that's what we're going to do. So right now we'll hit green check, and we have our tap drill size hole. So now what I want to do is get rid of the 3/8/16 hole wireframe spec. Now that's part of the model now. Okay, and we can even rename this 3/8/16 hole wireframe. And that's up to you how in detail you want to get. So we'll turn that off, and now we can start working again. Let's do the next hole. So let's work with this one in the middle. So it's 1.5 and 1.125. 3/8 reamed hole, let's say. So let's do a new level, and this will be 0.375 center hole wireframe. All right, that is active. we can again go into wireframe and offset these lines to create an intersection in the center of this block, at least in the 3-inch direction. It's going to be 1.5 inches from this side and 1.1 inches from this side. So let's get back into Mastercam and we will offset those lines. So we'll go 1.1 inches from here to here. Or my mistake, let's get out of there. Actually, what we can do right now is before you hit apply, you can just change this to 1.5 and click out of the box and it'll automatically move. Then hit apply, so that one's set. Now we'll go 1.125. Click here and down and hit green check and clear colors. And now if I rotate this, we're ready to do our next hole. Now, as I said before, we're not going to use the solids hole function for this. What we're going to do is we're going to go to wireframe, we're going to do circle, hover over the intersection here, create our circle at a diameter of 0.375, green check. So now we have our spec. Now, what we can do now is I want to go over some changes here. Let's say, for whatever reason, this is not the right diameter. Okay, go to the drawing and up 3/8 we drew it wrong. Let's say we click it, right click, and go to Analyze Entity Properties, and you can update the diameter here. Let's say we want to go to 0.5 inch. Okay, green check, it'll change. Right click, Analyze Entity Properties, 0.375, green check. You could also change the level in there like I showed you before. Alright, the other thing we can do is, I showed you how to use drafting earlier quickly. If we go to Home, or right click, Analyze Distance, and click from here to here, it gives us our distances quickly. It's more of a quick measuring tool in the software. So now what I want to do is I'm going to lose these lines because they're going to mess with my extruded cut. Then we'll get into solids, extrude, select the circle itself, so chain around, green check. Make sure you select cut body, very important. We're going to go through all. We will then hit green check. So now that 2D wireframe is there, our model has been updated. Alright, so I will pause here and we will continue with the rest of the holes on this workpiece. Okay, so let's work on the lower left hole of this workpiece. Should be a countersunk hole. We are going to override this drawing. We're going to go to 82 degrees, primarily because I want to use one tool for when we get to machine this. So that would not be normal if you went and did this, to print. We'll override that for this when we create this hole. So we're going to do this a little differently. We are not going to create geometry prior to locating the hole. So let's get back into Mastercam. And let's go to the hole function. And this is a countersunk hole 266 through hole. So let's get down here into a countersunk hole with a diameter of 0.266. Countersink diameter is 510. Countersink angle 82 degrees. 510, we're overriding the 100 degrees. 266 is the clearance hole. So all the specs are set there. This is through all. There is no chopped chamfer, so we'll omit that. Now the hole is set, but we need to get into the location. So let's go to Add Auto Cursor. Now we're working in this screen. If you hit the space bar, this little window pops up here, and we can type in coordinates, and those coordinates are based off of this gnomon. So that means if we go back to HO18P1 here, and we go 563 in Y positive and 438 in X positive, that means that we can type these in. So it's XYZ. So it's going to be 0.438, comma, 563 in the Y, comma, 0 for XYZ location. Then hit enter, and you'll see the point is positioned. Okay, hit enter again, and you'll see the hole is created. We go into here, we look pretty good. Okay, so there's our countersunk hole. Alright, double check our hole settings, 266 diameter, 0.51 for the countersink diameter, 82 degrees, looks good. Alright, so then we'll hit green check. So there's our hole. Okay, there's the locator for the hole. If we right click on that, Analyze Entity Properties, okay, we have our location. It's on level 5. Maybe we don't want a level 5, we'll go on level 6. And we have level 6, and this can be, let's see, whatever you want to name it. Okay, and actually we'll just call it location wireframe. And again, these names are irrelevant. As long as they make sense to you, we're good to go. So there's that hole. Okay. And now we can work on the next ones. So we'll take a look at our drawing here. And the drawing shows this counterbore hole. The counterbore hole, we are just going to extrude. We're not going to use the hole function in solids for this. And the reason for that is because I want to show you how to extrude to a depth. If we wanted to use the actual hole function, we would just do it the same way as a countersunk hole, except for we would select a counterbore hole and give it those specifications. So what I want to do is I'm just going to use the offset trim method, and we'll add a new level for this and just call it a C-bore hole. Wireframe. Make sure it's active. Alright. We'll get into wireframe and we'll go to offset. And let's take a look at the drawing. It looks like we're ½ inch in the X minus and 781 in Y minus. So we'll take care of the ½ inch now. 0.5 this way. Apply. And 781 in the Y. So 0.781 from here. Alright, green check. Right click, clear colors. So now it's located. Alright. Now we're ready to add some circles. We look at the specs of this hole. The through hole is 397, the counterbore is 719. So let's take care of the through hole first. So the through hole, 397. Select circle, select the intersection, create the arc, whatever size you want, type in a diameter of 0.397. Before you hit apply, just check it. You can change it later, but that's what we want to do. Then we'll hit green check. Now I'm going to lose my locators, okay, or as far as my offset lines. It's called the offset trim method because you offset what you need and then trim what you don't need. So now we'll go to circle center point and highlight this circle center, and you'll see it comes up so that you can pick the center of the previous circle. Make the circle some size. Before you click it, double check. 719 is the diameter. 0.719. Hit green check. And now we have 2 circles. So now we need to extrude cut them. So we'll go to solids and we'll go to extrude. I'm going to select the first circle first. Okay, this is going to be through all, cut body, green check. I'll then select extrude again. Select the counterbore, green check. This is going to be a distance. Make sure cut body is on. Distance, 1/4 inch. So we'll go 0.25. Okay, click anywhere on the screen. Make sure it looks good before you hit green check. There's our counterbore hole. So again, we could turn off the wireframe geometry. Okay. And you can turn things on or off. So if we just want to look at our model, there it is. We need our boundary and all the wireframe information. There it is. And that's useful later on when we need to get into other tool paths and referencing geometry and things like that. So let's take care of our final feature, which is a 7/16 14 tapped hole, and we're just going to do a sit tap drill, and we'll do this simply the same way we did the countersunk hole. So we'll get into the solids function. We'll go into hole. This is going to be the names are relevant. There's a solids manager, but we're going to remove solid history. We're going to avoid that portion of this for now. This is going to be a simple hole, and we're going to select the tap drill size for 7/16 14. We'll double check that, and that's correct. 7/16 14. That's good. Alright. This is going to be through all. Top chamfer's fine for now. We'll do an angle of 82 just to use the right tool. There's no, it's not to the standard, but that's what we're going to do. We will then do add our auto cursor position. Okay. And then we could work through this. So let's take care of this now. Let's just position this hole somewhere in space here. Right there. Okay. Then hit enter. And there's our hole, and we'll hit green check. We have no idea where it is. Okay. So now let's edit this. Let's click this feature, right click, analyze entity properties, and let's locate it. So in the X, okay, this feature is 3 inches minus 5/8. So 3.0 minus 0.625 equals 2 3/8. So go back here, and we will type in 2.375. In the y, 3/8. So we'll take care of that now. 0.375. We'll put this on level 7. Okay, hit green check. Now let's take a look at the solids menu, because this didn't update. Okay, just move the center point. Let's get into the solids menu, and you'll see that there's a big X here. And what's X'd out is our 7/16 14 UNC hole. I'm not going to go into this manager much, but just for fixing things like this, if you click on this and go up and hit regen, it'll move to where it needs to be, because it regenerates the algorithm to position that hole. Okay, looks good there. All right, now we're all set with the solids. We'll go to toolpaths, leave it there. Everything looks good. We'll go back to levels, and we'll just turn everything off except for our model. I'll label this 7/16 hole wireframe, and there we are. So there's our model. Okay, now we'll pause right here and let you catch up, and then we'll come back and create our stock reference for this, and we can start machining it. Okay, so let's start working with creating a new model for stock. Let's get in levels, and I'm going to add a new level, and this will be stock wireframe. Okay, and I'm just going to do a quick rectangle. I'm going to turn all this stuff off, except for I can leave the model on. All right, and I'm going to do a new rectangle, and I'm just going to click that corner to that corner of the block. Okay, 3x2 instead of typing it in. We'll hit green check. Okay, so now what I want to do is I'm going to turn the model off, and I'm going to extend these two sides over for 1/8 of an inch oversized material, so a 1/16 a side. We're not going to worry about the Y. We're going to assume that's been machined or as is. We're just going to worry about having extra stock length here. So let's get into the offset area. We'll go 1/16 of an inch. Click here, green check, right click, clear colors, and then let's connect these longer lines by going to modify length. Let's select a distance of, let's just say 1/4 of an inch, and the reason for that is I want to go back, hit green check, and use divide, which is sort of like trim, and trim the tails off and trim these inner lines so that you get one solid rectangle, right? And the corners do touch. So we'll hit green check, and let's do a new level, and this will be stock model. All right, this is active. Go to solids, extrude, chain the outer boundary, green check, distance 1/2 inch. We're going to create body. We're going to make sure we go down. It goes that way. We're good there. We'll hit green check. And the only thing we need to do is right click on our stock model and make it a different color. Let's say red. Okay, so there's our model. There's our stock. And now we're ready to import our vise and modified soft jaws. So we'll come back, we'll modify the soft jaws next, we'll import them in, update the soft jaws, and then we'll merge all the files together, and then we can start getting into some toolpaths. So we'll pause here. This is the end of the part geometry creation, and then we can get into getting this thing set up to machine. Okay, so this is the lecture folder in Module 1 on Blackboard, and what you see here is going to be the example 1 drawing, what we're working with. You're going to see the standard Curt jaw. You want to download this now. You also want to download the Curt DX6 with no jaws. Download both of those now. Okay, this Haas Post content folder we'll work with in a minute. Then below here you'll see the this video and this cutter compensation type video. Now, these two we're going to import or merge into Mastercam and work with. The Haas Post content folder we'll use when we get ready to machine. So first thing we need to do is modify these vise jaws. Okay, so let's get back into Mastercam. I already have them downloaded, and what we need to do is, there's a couple of ways to do this. You can modify the levels later. I'm going to turn the stock model, all the levels off, all the part levels off. Then I'm going to go add a new level and call this jaws. Okay. Then I'm going to do another level and call it vise. Alright, so I'm going to make sure level 10 is active. I'm going to go to File, Merge. I'm then going to select the standard Curt jaw, hit open. Alright, and you'll see that you have options here. We can move it. Okay. Levels is what I want to focus on. Okay. We want to make sure that we go to the active level. Merges incoming part geometry to the current part's active level. Should be level 10. Okay. Click here, make sure active level's on. Now, we can move this around now. So if we go to dynamic, put the gnomon right there. Okay. Now we can spin it. But you'll notice we don't have a Z-axis. We need to come down here and select 3D. Now we can rotate this vice jaw 90 degrees this way. Hit enter twice. Pick the green, which is about the Y, and go negative 90 degrees. And that is good for now. So we'll hit green check. That looks good. Okay. So for right now, we will hit green check. Alright, and we'll start working with this. Now, what I want to do now is I am going to bring in the vise while we're at it. I'll put the jaws in the vise, and we will, process right through this, machine the vise and things like that, or machine the jaws and go that route. So now what I want to do is go again to File Merge, but first make sure Vice is selected as the active level. File, Merge, select the current vise, hit Open. You'll see it imports in. Okay. Now, we're going to go to active level. Okay. And then what we're going to do is we're going to hit green check. Alright? Because I want to turn the jaws off. Also, our level came in with it. It has no entities on it. See right here is a 0. So what I do is right click. Alright? Clear empty levels. All. Let's make sure that's gone. So now we have the vise and the jaw. And the part. But right now the vise is sort of in the way. Okay? So what I want to do is go to Transform Dynamic. Select everything. Hit Enter. I'm going to end up just selecting just the center here. And what I'm going to do is I'm going to shift this thing over. Then I'm going to rotate it how I want it. So it's going to be negative 90. Or 90, sorry. And then I'm going to kick it this way. It's going to be negative 90. And that'll work. Okay? So I'm going to hit green check. So now I want to right click, clear colors. And that's pretty good. Okay, what I want to do now is there is the actual model of the guard for the vise. I'm going to get rid of that. Okay, and also I don't need to worry about the threaded rod or the actual carriage portion, the part that moves the movable jaw on this vise. That's good. We'll try to keep it as simple as possible. So now that we have that, what I want to do is position my soft jaws. So I'm going to turn the jaws level back on. Okay, and what I'm going to do is I'm going to move it. So I'm going to go to Dynamic. I'm going to select the soft jaw and selection. I'm going to put the gnomon on the back side of this hole. And then click this little center sphere to give me full access and movement of the jaw. Then bring it over to the vise and select the actual threaded hole in the vise and click it so it merges. Everything looks good. There's not a gap underneath here, so these jaws are not symmetrical. This hole is offset. That looks good. So that's fine. So let's hit green check. Okay. So now let's copy this jaw. So let's go to Dynamic again. Let's select the jaw. Let's hit End Selection. Let's just put the gnomon at some center portion here. Go to Copy. Okay. And I'm going to drag it over. Alright. And I'm going to spin it now. So about the Z or the blue. So it's going to be 180. Then I'm going to hit Apply. Now, when you hit apply, you're back into the window. So I'm just going to reselect the jaw and hit end selection. Put the gnomon on one of the clearance holes for the bolts. Select the center sphere. Don't worry about it, it's still on copy. We'll fix that in a minute. We'll snap it to that circle. Select move. Okay, that looks pretty good. Alright, I'm going to hit apply. Now what I want to do is bring these jaws together. So I'm going to select the jaw itself and the movable vise, the back part of the vise. Okay. So now I want to hit end selection. I'm just going to select the midpoint here. Then I'm going to select the y-axis only and bring it together. Okay. Then I'm going to hit green check. Now I want to right-click clear colors, and I want to make sure everything looks good. I want to make sure that they're all in line. Everything looks good. I don't see any issues. So you know, I'm using a space mouse, so my movements are going to be a little different than what you can achieve. Okay, so it looks good. All right, we're in good shape. Okay, so now what we need to do is we need to machine these for the part, and the part is back over here. Okay, so we need to draw some geometry. So I'm going to leave the vise on, but make sure the active level are the jaws. I'm going to draw a line, and I'm going to snap it to the center of these. So if you hover over the midpoint, it'll kind of snap. Draw a line straight over. Then hit green check. I'm going to go to top view now. So then I want to have the step in this draw be a little bit under the width of the part. So I'm going to offset this, and let's say I want the total width to be, if it's 3 inches, it'll be 3 and 7/16. So let's just, instead of actually getting a calculator out, you can go 3.4375 divided by 2, enter, and it gives you the number. So you can do the math in some of these columns. Click over, green check, right click, clear colors, and then right click again and go to analyze distance and select these lines to make sure you got 3.4375. Now I did my math wrong. It should be 2.4375. So let's just do that again. Alright, offset. I'm going to go 2.4375 divided by 2 and click both directions. Green check, clear colors, right click, analyze distance, here to here. Okay, 2.4375. Good. All right, we'll hit green check. So now we need to machine this material away. Probably, you know, we don't want to go all the way down to the jaws. What we can do is we can look at this. If we right click and go to analyze distance, here to there, and it's 1/4 of an inch. So what we need to do is we'll probably go down 200 thousandths. All right. So let's get ready to actually do some tool paths. The first thing we need is a 0. We need a point on this vise jaw that we're going to edge find and set our work offset to. And we're just going to go to this top left corner for this part. So we're going to start messing with the planes manager now. The planes manager are the 0s, not only for Mastercam geometry creation and all that. It is where your work offset is, linking the Mastercam program to your machine tool. So we want to do a new plane. So we're going to go with the pull down. We're going to go dynamic. Okay. We have a gnomon attached. We're going to click right there on this corner. Okay, pretty simple. And then down here, make sure set as work coordinate system, T-plane and C-plane are on. The work coordinate system or world coordinate system is the overall 0, on your workpiece. Okay, but for now, it is very important that your WCS matches your T-plane and your C-plane. Very important, because what happens is, the only time these really change, arguable with C-plane, is when you want to do construction. I find that sort of obsolete, but you can work with it. The thing here is, if you want rotary axis moves or Mastercam to kick out A or B or C axis moves, it is the difference between a WCS and a T-plane. So it's very important for our 3-axis work that these are all the same. Okay, let's hit green check. So there's our new plane. Now we could rename this. It's probably not a bad idea, and we'll just call it fixture. Now, the other thing I want to do is I want to create what's called a view sheet. And the reason I want to do that is because I want to be able to re-access this at a later time. So there is a separate YouTube video on my channel for view sheets, but let's use them now, because this is how this all flows. So let's get into view. Alright, and make sure view sheets is on. And down in the bottom here, you'll see view sheet 1 pop up. Let's right click on this, and let's rename this as fixture. And this will be important for us going back and forth later on. So we'll click, then we will right click and say save view sheet bookmark. Okay, very important step. So make sure you have that set, and then we can start machining. So I'll let you catch up there, and we'll come back and we'll import our post and start machining this workpiece. Okay, so what we're going to do now, right prior to machining, I was debating whether or not I wanted to step these jaws or not. You could use parallels in here, but we're going to step them. So what I want to do right now is I'm going to move this vice jaw back 2 inches. And the only reason I'm picking 2 inches is because we use a 1, 2, 3 block, flat, and then clamp on it. It's very important that you clamp on the vise or have the vise being squeezed when you machine it. Otherwise, this jaw is just loose in space and bad things can happen. So let's get into dynamic. All right, let's select both portions of the jaw, hit end selection. We're going to select the middle. We'll select the y-axis. Then we'll type in minus 2.0. Enter, enter. So now they're spaced, okay, 2 inches apart. Let's check that. Right click, analyze distance. Bottom of this jaw to here, 2 inches. We're good. Now, our lines don't work out anymore. That's okay, because what we can do is we can go to wireframe, modify length, type in a distance of 2.0, and click these lines. So now they're extended. Now, we are going to cut a little bit of air if we do it this way. If we have the cutter come in and machine that, that's not the end of the world. We can be more efficient and just do each jaw separately, but let's just leave it like that for now. So we'll hit green check. Now, let's offset a line in on each one of these jaws. And what that'll do is it'll give us a nice guide curve for our chain. So let's hit offset. Let's hit a distance of 0.2, which is fine. You can go 1/8 of an inch. 0.2 is fine. That's what was on here. We'll select this line, go over. This line, go over. Okay, then hit green check. So now we have right click, clear colors, our lines. Now let's use the divide tool and clean this up. So I'm going to get in here and I'm going to lose these outer lines because that material is going to be gone. We don't need that. Okay. The other thing we can do is we can lose the centers here. Okay. Like I said before, that's debatable. Right then we're going to leave them, but let's lose them right now. So now that's essentially what we're going to be working with. So now we're ready to actually extrude this down and get this part into a 3D state. So now get out of here, and we need to get some geometry on these jaws. Okay, we can't really reference these edges right now. So in wireframe, we'll go to curve on one edge, and then select these outer lines. Okay, and just creates wireframe geometry on that intersection. So hit green check. Then we got to go to divide again and get rid of the geometry in between this area. That better references what we want to extrude down in this cut. So now we're ready to extrude this. So let's go to solids. Let's do this one at a time. Hit extrude. Select this chain. There's the chain. Hit green check. And then we want to have a distance of 0.2. I'm going to leave a little bit away from the jaw so we won't hit that. That'll work out fine. It could be less. It's up to you. But I think that'll work fine. That's what we're looking for. Okay. So we'll hit green check. So let's do it again. Extrude. Select the chain. Hit green check. 0.2 is there. You can change it if you want. Hit green check. So now our 3D model is correct. The problem is now is we don't need this wireframe. We can't just delete it because it is defining this cut. So in Solid Manager, I want to really delete. You'll see on these are our solid jaws. This is the history. You can see you can go back and edit these if you want. But to be honest, I don't find that totally helpful sometimes. I think it's sometimes better to go into model prep and modify things if possible. So for right now, just to keep this simple, what I want to do is select all levels, or not levels, I'm sorry, all solids, right click and go to remove solid history. Now these solids are just solid bodies. Okay, we removed the association between the 2D and the 3D. So now if we click this line and hit delete, nothing happens. If you do that if you try to delete a line and you do not remove the solid history, you'll get an associated geometry error. So it'll ask you, do you want to delete this? And it gets kind of weird. So you're better off by far to just remove solid history, and it'll help you, especially on simple parts like this, because you can always go back in and modify later. It's not the end of the world. So what I want to do now is I'm going to get into levels. I'm going to turn the vise off. That helps so I can see better. Then I'm going to get into here, and I'm just going to delete this 2D geometry. We don't need it right now. Okay? We'll work with it as is. Okay, so I'm just hitting delete in the keyboard. So there we are. turn the vise back on, and we are good to go. Now, one issue we have is we do need something to reference our stock, okay, for these vice jaws. Okay, so this is the results of what we want. You don't really need it. It's up to you. It's how realistic you want to get. We could actually import the jaws again and put them in place and work with it that way. But what I'm going to do is I'm going to end up just doing a geometry of a bounding box on both of these jaws and treat it like one big piece of stock. And although it's not 100% realistic, that's what we're going to kind of work with. Okay, so to do that, we need to start actually getting machine toolpaths built. So we are essentially all set here for now. We have our fixture view sheet all set. So that's important, okay? Double click on it, you see it goes back to where we're at. This is what we're going to be looking at. We're going to assume that there is a 1, 2, 3 block in here, remember that, okay? And then we can actually machine these jaws. So first thing we need to do is we need to get into the lecture, and then make sure you download the Haas post content folder. So I'm going to click that now. And mine downloaded is going to be right into my downloads. And then I'm going to get back into Mastercam, and I already have that file open. But what you want to do, okay, is take that folder. All right. So I'm going to get into. I'm going to minimize this. So let's minimize this screen. And I'm going to minimize Blackboard. All right. And I'm going to right-click and go into the File Explorer. Go to Downloads. You're going to want to take this generic Haas 3-axis content folder that you just downloaded, click it, hold it, and drag it into the window here. Okay? And you see mine is going to have me, you know, I already have it in there, so I'm just going to X out of here. And X out of all of this. This will not happen to you. Okay? So we're good to go. That's what you need to do. Now what happens is when you go to Machine, Mill, you're not going to have this right away. You have to go to Manage List. Okay? In here, you're going to select the generic Haas 3-axis mill, hit Add, so it goes into the machine definition menu items, hit green check, and then when you go into the pull down, it'll be available here. So make sure you do that. Click right here, and now we have a machine group. Okay? The machine group is really not changed a lot if you're going from lathe to mill to wire to whatever. So for right now, a machine group just controls. A machine group has the files, tool settings, and stock setup right here. A toolpath group, you can have multiple toolpath groups in a program. You can have toolpath groups on top of toolpath groups on top of toolpath groups. They're just there for organization. Okay, and I'll show you how to organize that. All right. So we are going. There are a couple different ways to define stock in Mastercam. We're going to use the stock setup for this first one. So what I'm going to do is I'm going to click anywhere in here. I'm just going to click Files, and you'll see that when you click that, you got Files, Tool Settings, Stock Setup. You have the same thing here. All right. Not much to do in Files. We'll leave that for now. We will go to Tool Settings, and you could define a program number here. Feed calculation. I'm going to go from material, and these are just going to be aluminum. That's fine. We'll get into speeds and feeds when it's appropriate. All right. And work with it from there. I do have libraries we could work with, but we'll end up just typing them in for this one just to keep it as simple as possible in that respect. We are going to want to assign tool numbers sequentially. That means it's 1, 2, 3, 4, 5. That's how we're going to operate. We're going to warn of duplicate tool numbers, all right, and that should be enough. All right. So then we'll hit. One thing I want to do here. Let's just double check aluminum what the settings are. So if we click aluminum, the base cutting speed is 1,000, and the basic feet per tooth is 7. That's okay. We are going to have to be careful when it comes to high-speed steel. We might have to reduce the surface footage. Surface footage probably around 200 if it's aluminum. Some of these might have to be reduced, but these are pretty generic. Okay, so that's okay. Even the 7,000. We can tweak this, okay? It depends on the rigidity of your setup, but this is a good overall base surface footage and base feed per tooth. Okay, so we'll hit green check, and that's fine. Now, we are probably not going to be working with 2024. You can go into Select, go to Mill Library, and you'll see the rest of them, okay? Sometimes you get in here, and there's actually create new or change library, and you'll see that I have my own library here, and at some point I'll make that available to you. I have a lot of detailed speeds and feeds in there, but I don't think that's necessary for now. I really want you to pay attention to it. So 6061, let's green check it, and let's go to edit, and you'll see that it is a little bit slower, okay, because 6061 is a little bit tougher, and these are generic speeds and feeds. Okay, so we'll live with that. That's fine. That's a little better. I'd prefer that you ran it on the slow side to make sure that you don't break things than to go crazy and break stuff right off the bat. It's important to be accurate and not crash, and that experience will make you faster as you go. So we'll go with 6061. That's going to be probably what we're working with. That's what we have available in the shop. Now we'll go into stock setup. Okay, and the stock plane, all right, I always put the stock plane as top, but we're just going to leave it as fixture for now. That's fine. It depends on how you're starting. Fixture is going to work with the work offset here. I want to display the stock. Now, the issue here is the vise is on. So let's get into levels, and it won't let you because this is open. So let's just hit green check for now. Get into levels and turn the vise off. So all we have are these jaws. It's the only thing on. Back into toolpath, stock setup. Now what I want to do is I'm going to select all solids. So here is the outside spec on our stock. Let's hit green check, and you should see a box come up that's dotted. That represents our stock. Like I said before, it's not 100% accurate to the true stock. We do have a lot of hollow space in here. But the toolpaths we're going to be using are very simple. We're just going to use contour for this. So it's going to cut a lot of air anyway without a lot of extra chaining. And I don't want to get into the more advanced toolpaths yet. So we're going to just use this for stock, and it gets into what stock setup is before we get into the different types of ways to define stock. So that's a good base example. So that's what we're looking at. Get into planes, levels, and turn our vise back on. So we're ready to roll here. All right, go back to toolpaths. Now I'm going to minimize the properties, and we're going to work with toolpath groups. So this first toolpath group, if I click on here, left click, and hover over it, okay, it'll turn into a text box. So I'm just going to call this fixture. All right. Now, the organization of this tree is critical. So I want to have another toolpath group that's going to be part. Okay. So what I want to do is go to machine group. Very important. These leader lines and where they go to is very important. If I right click and do new toolpath group here, it'll be associated with this leader line here. We don't want that. We want to have separate access to it. So we go to machine group, it'll be associated and have another tree root here. Okay, so if I go right click, groups, new toolpath group, you see the leader line change. Okay, so this is going to be part. Okay, now that's fine for now. I just want to go over that. You'll see that fixture has nothing there. What I want to do is this little red cursor, hit the up button, and now we're ready to roll. The only reason that didn't have a plus next to it is because there's nothing to add. There's no toolpaths yet. Okay, so we are ready to actually start defining cutting operations. So I'll pause there, and we will continue with our first contour toolpath. Okay, so let's get some wireframe geometry on here that we can work with. Now I know we deleted some things earlier, but that's fine. I'm just trying to have a little bit of redundancy in this to have you working with different tools and to see it again and things like that. So we're going to go to wireframe, go to line, and I'm just going to select a line here and select a line here. Okay, I'm also going to select a line here, and just to change it up we can also go to curve on one edge and select this line. So there's a couple different ways to do that. I'm going to levels and make sure that the jaws we're on were good there. So this is going to be our geometry we need to machine this. Alright, we're just going to do 2D geometry, no 3D geometry for actually machining right now. Okay, it's not 100% necessary yet. We could have, but not right now. So now we can go to toolpaths, which now pops up after you have a machine group. And we're going to go to contour. Okay, we're going to select this chain and this chain. Okay, making sure the direction makes sense for climb cutting. Okay, then we'll hit green check. Now we can go a contour toolpath type, 2 chains, makes sense. All right, we can go to tool, and let's go to select library tool. And what we're going to select is a half-inch carbide cutter. Well, the filter's on. What the filter does is organizes the entire library into what you need. So we go to the filter, and this is how we select what we want to filter the list, what we want to see. So we want to see none. Select only flat end mills equal to a 1/2 inch diameter, then hit green check. There's our 1/2 inch cutter, hit green check. Notice that it's tool 1. Okay? Our speeds and feeds are on the slow side. They are. Okay? But I would much prefer that you run it at this surface footage and this chip load, then break the cutter. So for now, we will do rapid retract. This is fine for us. Okay? Again, if you go into a speed and feed calculator, or even if you double click into here, you get to finalize your properties. You can see the tool specific surface footage. This is a high-speed seal tool. If we go to carbide, if I remember correctly, it should be about the same. If we right click and reinitialize speeds and feeds, it's the same 100%. So if we go to right click and get into this feed and speed calculator, we could tweak these values. Okay, but for now, this is fine for us. The most important thing is number of flutes. Make sure that's right. And again, all that stuff is in this window. Right click, and it's going to be into the feed and speed calculator or reinitialize speeds and feeds. Okay, but again, as you work with this, we'll get more into that. The generic settings are fine for now for 6061 aluminum. That's ideal for us. It's pretty conservative. Okay, the holder. I'm not worried about the holder information right now. The only thing we'd have to worry about maybe is projection, but it'd be very unlikely to shank out on this workpiece, so I'm really not worried about it. You could edit the projection, but for now, I'm not gonna worry about that. Cut parameters. There is a video on Blackboard in Module 1 that goes over compensation type. Pause this video now and watch that video. Really important. Okay? So after you watch this video, we're going to use wear comp. And the reason for that, as noted in the video, is we don't have to type in the diameter of the cutter into the controller. It'll save you time. Okay? So don't worry about it. So we use wear. We don't need any depth of cuts. We're not going to worry about it for this one. Okay, we can break this up into so many depth of cuts. We're not going to do that. Lead in, lead out specs, we're going to lead on. The overlap amount, we'll put in 30 thousandths. That's how much it overlaps. It's the overlap, it's past the workpiece. So you want to overlap a little bit, usually no matter what you're doing. Otherwise, you can get little ears and things like that. So everything here is going to be fine. I'm not going to have you change as much. We will get into this later, but we'll leave default for now. Breakthrough amounts we're not going to need. Multi-passes we're going to need. So what multi-passes does is it offsets the toolpath over and over again. We're going to leave it off for now just to see what happens. Okay? We don't need tabs, linking parameters. Now, we want to turn clearance plane on at 2 inches, only at the start and end of operation. We're going to use absolute on all of these for now. Important. You'll see when I change that, it went to a depth of -0.2 because that's where the geometry is. We do want to change top of stock. That's going to be 0. That makes sense because it's absolute to this 0, 0, because that's what's currently on. Okay? So if you ever have questions on these, we will go to incremental and associative as needed. Just hit the help menu, and it is very helpful. So if we get into here, absolute incremental values, read this. Very helpful. Okay? If you're lost. Let's get back into here. We're good to go. This is all set. Again, all that goes over is, you know, the top of stock and depth right here. Okay, always from 0, 0 absolute. Incremental values are relative to other parameters or change geometry. Other parameters or change geometry. Depth and top of stock are different from clearance, retract, and feed plane on purpose, and you'll see that in the next module when it comes to drilling. Depth and top of stock are relative to the location of the chain geometry. Our chain geometry is down at that point, -0.2. That's why you go incremental, it goes to 0. Absolute is -0.2. Makes sense. Top of stock, incremental, or absolute, doesn't change. But you can change it. So if we go, let's say incremental, top of stock, there, it's 0.2. If we go absolute, top of stock is here, is 0. Okay? So make sure you pay attention to that. Then again, all of these are based off of top of stock. Okay? We're going to ignore home reference points for now. All right? Arc filtering we're going to ignore for now. Don't worry about that. We'll get into that in a later video. Planes. Make sure they are all fixture. Important. Coolant. We're going to turn that on. Okay? Now we can hit green check, and we will see our tool paths. Okay? The yellow are the retracts. You'll see it retracts over, and then you'll see these real tall retracts. That is the going 2 inches to clearance plane only at the beginning and end of operation. The green is the lead in, the red is the lead out. Right? And you'll see that right now this is not really what we want because all this stock would still be here. Okay? If we go to backplot, which is right here, and then hit the play button, you'll see what this is doing. Okay? Again, it's sort of what we want, but it's not exactly because we're leaving all the stock to the left and or right of the cutter. Okay? Let's get out of here and let's go use multipass. So when we get in here, we're going to go to multipasses, turn it on, and the spacing, this is a 1/2 inch cutter. So I want to do a 1/4 inch spacing, taking half the cutter each time. I'm going to have nothing for finishing. I'm not worried about that. I'm going to finish pass only at final depth. There is no depth of cut, so it's sort of irrelevant. I am going to go to keep tool down, and then we're all set here. The only thing I need to change is going to be the number of passes. Let's just change it to 5 for now. Let's hit green check, okay? And you'll see that that is actually too much. So if we regenerate this, now it automatically regenerated, but hit regenerate, okay? And that redoes the algorithm of the parameters you just put in. So if this is for whatever reason X'd out, just regenerate. Okay, you'll see this generate toolpath is a new Mastercam 2022 feature. If that's off and we change something and hit green check, you'll see it turns red. It's a dirty operation. Regenerate, you're good to go. But thankfully they put this in so you don't have to worry about it. So when you make changes, it automatically regenerates because let's face it, you're going to regenerate anyway. So here, and let's watch what happens here. Okay, there we go. We're good, except for it's actually not cutting enough. These lines were an illusion. These are the retract lines. If we go to parameters and turn keep tool down off, green check, you'll see that they turn into retracts. Okay, the blue lines are cutting. That is actually not cutting enough. So let's go back into parameters. Let's change this to 7. Hit green check and regenerate. That is just about right because this represents the center of the cutter. Okay, so what I want to do is hit backplot, slow backplot down using this little slider bar here and hit play. That's about right. Okay, now if you want to see what happens without having to play with the slider, you can hit S on the keyboard and it goes through. I'm hitting S, or you can hit B for back and it goes backwards. Just so you know, so S for forwards, B for backwards. So this looks good. We'll run it in backplot. Alright. So there is our multi-passes. So we're good there. Okay. Now I don't want to see these toolpaths anymore. Okay, I want to focus in here. You can hit these 3 squiggly lines when this is checkboxed, and it'll turn them on and off to help you just see what's happening. Now I want to do a contour and take care of just one pass to get rid of these edges. So what I'm going to do is go to contour. I'm going to select that chain. I gotta be careful because that's going to be conventional cutting. So let's change direction here to make sure the cutter is climb cutting. Then we'll select this one, climb cutting. Okay, hit green check. Go to tool, we'll select tool 1 again. Speeds and feeds are going to be defined because they're saved from the last operation. We'll go to cut parameters. Everything here should be okay. Depth of cuts is fine. Lead in, lead out is fine with the 30th out overlap. Multi-passes we can turn off. We don't need it. Linking parameters are fine. The coolant should still be on because it saves our settings from the last contour we did. Hit green check. And we are good to go. Okay, it looks pretty good. We'll watch it in backplot. Hit play. And you'll see it comes in and it's climb cutting. Cutter's going clockwise. Come up and go over. Okay. So those 2 are done. Now, let's talk about a couple other things here. We can label these. So there's 2 ways to do this. You can go to parameters, and you can go to the tool here and type in, this is going to be rough sides of jaws. Okay? That'll type in as a comment. That'll show up in your program. You could also click here and hover, just like you would to create a new toolpath group, or to rename a toolpath group. And this can be step and jaw. And they will go in your program, and I'll show you that in a minute. So right now we're all labeled, we're good to go. One thing on that, instead of hovering over this, you could always right click and you could rename it. So you could edit, go to groups, and it's going to be renamed. So I'm not worried about that for now. So we're good there. Let's select fixture. So when you select fixture, it selects every toolpath in there. That's why it's important that you don't put the other toolpath groups that are separate work offsets or separate in any way underneath this operation. This grade leader line is critical. Where they go, very important. So these two are selected. Let's look at this in the more, I guess it's fancy, the more accurate way to look at this, not backplot, which is this one. Let's go into verify. It's going to open up a new window. So give it a minute to load. And you'll see verify pop up. There it is. So now you see our stock. Now we don't see our vise. Why not? Let's X out of verify. Let's go into simulator settings. We're right here. In simulator settings, we need to go to fixtures and make sure that only the vise is on, because if the jaws are on, in theory, we might hit them. You shouldn't, because technically that material is already gone to what the software thinks. But let's just leave the vise on alone. We'll hit green check. Now we can go back to verify, let it load, and you'll see our vise. So now we'll slow it down, turn a couple settings on. We'll do op change, that's fine. In verify, we'll make sure color loop is on. And other than that, I'm going to put the precision and performance slider bar in the middle. That is just how accurate this is graphically. So let's hit play, and you'll see it cut. And this takes 4 minutes. Again, it's not the most efficient toolpath, but you see it does plunge, and it looks like it's leaving material, but it's not, because that is not there. And that is the issue with not being accurate with your stock. It is not critical for this operation. To be honest with you, I probably, in the shop, I wouldn't even verify this. I wouldn't even go to this screen, because this is so simple that backplot is actually ideal. When you go to backplot, now, let's say you want to see both of these in the toolpath lines. Both of these are highlighted. Okay, hit green check. If you want one of them off, just go in here, select them separately, and that little green checkbox is really what tells you what's on and what's off. Select both. They're both on. Hit backplot. You can watch it run. Now, if you want to see a representation of what the end mill is doing, hit this little quick verify on, or simple verify, and it shows you what's going on. All right? And that's ideal. So we're good there. So our jaws are done. So we can hit save. Very important to save off, and I haven't saved this yet in a while, so let's hit save. Okay. And now we're ready to look at the code for this, because these jaws are ready to be machined. So we're ready to go to the machine, essentially. We double click on fixture, that's where we're at. It's fixture offset. We'd have to edge find that corner of the jaw. Okay, touch off the top of the jaws. We're good there. So we want to post this code. Hit G1, hit green check. I am not worried about the name right now. Just leave it, and NC file is fine. So hit save. Where you save it does become critical. But you're gonna want it on the flash drive. But until I get out of here, I save it on the flash drive when I'm done with editing. So this is the Mastercam Code Expert. A lot of times I work in here. I'll delete some things. I'll add some things. I can add my number here if I wanted to. If I forgot to, things like that. Right now you'll see these comments that we added. These comments are the same as these comments. So just to point that out. And you'll see that things, the Z's are red and things like that. You'll see work offsets, smoothing settings, things like that. Tool callouts, but that's your code. And then you're going to want to file save as. I always save it as a text file. It's irrelevant. And again, save it as something very simple. It's easier to upload. And then bring it into the machine tool. So after this, after you get to this point, you're ready to bring it to the machine. So that's really it. I X'd out of there. That's it for these soft jaws. So I'll pause there, let you catch up, and then we'll get into the actual part machining. All right. Okay, so let's click fixture here, turn our tool paths off so we can see what's going on. And now we're going to have to position this jaw a little differently. So what we need to do is kind of protect the 2D wireframe geometry that we have. So to do that, let's put it in levels. So what we can do is, let's just do a new level, and this will be fixture, cut, wireframe. Okay, something like that. Then what I want to do is select these lines Okay, I want to right click, and I'm going to go to Analyze Entity Properties. I'm going to put them on level 12. Now I have multiple lines selected, so you have to get this Propagate button here, and hit green check. And you'll see we have 4 entities there. That's good for now, just in case we got to go back and change it later. The only thing that we might happen, again, we might have to move some of these around, but we're going to assume that they've already been cut. It's unlikely we'll have to go back, and it's not a big deal if we do. You could have double setups, one to do the jaws, one vise already done with the part in it. I don't know if that's really worth it. Not for this setup. Okay, so let's turn that off. Okay, and what I want to do now is we need to turn our model and stock model on for now. Okay, and this is what we're going to move. So we're going to move that to there. But we really need to turn everything on, because if you only move the model, the geometry won't go with it. Now, do we need this geometry? Not really. We could delete it. We did delete solid history earlier, so it is sort of relevant. But let's bring it with us just in case. So let's select everything here. Okay. Time to go to Dynamic. Select the middle of this part right there. Okay. So now the middle bottom of this part is selected. Let's go into the machine, and actually let's hit Escape. I want to change that around. Let's select everything again. Go to Dynamic, and I want to select this side, only because I want it against the solid jaw in case I have to move the jaw. Okay, in case I have to move the jaws around to fit this workpiece. So let's snap it to that line there. That looks good. Okay, that's good. Alright, and you'll see now why I did not, how I snapped it that way, because I had to move this jaw in. So let's hit green check. So now what I want to do is I want to move this jaw in to represent this. So let's go into Transform, Dynamic, click those two, hit End Selection, okay, and then we'll move this in. So we can go here, select the Y only, and then select the corner of the part and it'll snap to it. So we're good there. So let's hit green check. Okay, right click, clear colors. So now our part is positioned. So now what I want to do is I want to have a new 0, 0, a new work offset. That is the part. That's going to be a new plane. So we have the fixture, which is there, and that's good for our fixture 0, 0. We need to hit up here and go to Dynamic again, and so I'm going to select the top left of this workpiece right there. It's very important that you're on the outside here, because if you're on the inside where the actual part is, that's not there yet. You're going to edge find here, okay, or probe there, wherever you're going to do it, and that's going to be the 0, and then it's going to machine away from there. Okay, make sure Set As is correct. All of them are on. We're going to rename this as Part. Hit green check. So the part is on. The part is all set here. Again, I probably didn't go over this earlier, so there's only one. But you can move around and have different WCSs, different C planes, different T planes. So for us, for right now, make sure they're all the same. Okay, we only have one work offset, which is 54, so we can leave this work offset as automatic. That's fine for now. We'll get into that. We have multiple work offsets later on. This part does not. It's always going to be 54 because there's no reason to keep this work offset, because this part can shift left or right. There's no reason to do that. So then we're good there. So go to Toolpaths. And now what I want to do is position this in a way that makes sense. I also want to turn the levels I'm using on or off. So I'm going to go through and make sure I turn off all the 2D type things. Okay, we're good there. That's what we're looking for. Okay, so now I want to do a new view sheet by hitting the plus down here, and this is going to be Part. Then I'm going to right click and save view sheet bookmark. Make sure you watch the video on my YouTube channel on view sheets. The nice thing is if I go to Fixture or Part, notice that the levels change and the work offsets change. Okay, so you can go back and forth and it saves what you have, which is nice, especially the planes, because right now the part is on, fixture is on, and vice versa. The only thing it does not save is the position of things, which is why that can get a little funky, because you'll notice that I move this jaw in, that jaw is in now. If I go to the fixture and I go to levels and turn my fixture cut on, it's there. You know, it's going to cut that far apart. If you put a note in there, there are ways to do that, to mark that. That's fine. You could label it in here. But again, sometimes if it's fairly advanced, I'd put a whole new vise setup in, copy this whole setup, move it over to keep them separate. But we're probably never going to cut these jaws again. Let's say this is a one-off part, or you would keep the jaws. I wouldn't worry about it. I don't think this part warrants it, so we'll try to keep this as simple as we can for now. So here is our part file. This is ready to be drilled. Okay, what I'm going to do is I am going to go on my levels, and I am going to turn off the stock model. Okay, just for right now so we can see what's going on. Okay, this is what we're going to be machining. Okay, so I'll pause there. I'll make sure we save. I'll pause the video there quickly. Make sure you get the part in position. Make sure you set up your work offset, set up your view sheet, set up your levels, and we'll continue shortly. Okay, so let's get into drilling this. What we're going to do is we're going to spot drill the 2 tapped holes in this countersunk hole. We're going to do other hole operations here. We're not going to drill them. We're going to use helix bore and circle mill for these. So first thing we need to do is get this red cursor down below part and then minimize our fixture toolpath group. Now in part, what we can do is start our operations. This is where the next toolpath is going to go. Let's select drill. All right, there's no chaining dialog box like contour. This is just going to be hole locations. So let's pick, okay, we can pick the surface of this countersink, and it should give us make sure that this is flush with the top of the workpiece. Same way here, same way here. And there's other ways to select. You could do the whole surface if it's a hole. It could be a circle, things like that. But that's what we're going to do for this one. Okay, and then we can hit green check. Now, these 3 holes are going to be drilled. The tool we're going to use, if we go to Select Library Tool, we're going to go to the filter. We're going to select None to turn them all off. Then we're going to go over to Spot Drill. So find on the list, Spot Drill. We're going to go equal to 0.375 or 3/8 of an inch, green check. There's a 3/8 spot drill, green check. Okay, so there it is. Okay, that is fine. This speeds and feeds are fine for this. Okay, notice they're a little bit slower because this would be high-speed steel. Okay, let's double check our speed and feed calculator. Double check that. Everything looks good. It's actually a reduction for drilling, 60% for drilling. Okay, so that's fine. We'll hit green check and we'll live with that. One thing you need to be careful of is, and in my experience, is you got to watch your feed per tooth, and then how many actual flutes it's calling for on the cutter. So this is 4. That's not accurate. In reality, in the shop, I always do 1 for drills, and the way I calculate my speeds and feeds are inches per rev. So when you're looking things up for drilling, it's inches per rev. So I always go 1 flute on my cutters. And the reason for that is because even though it has 2, when you spin the cutter a full 360, or even when you spin it 180, there's no more material there. So you need to make sure that it's calculating, you know, essentially for 1 flute, because they're 180 out, if that makes sense. So as you advance the tool and the tool is spinning, if you know, and you calculate for feed per rev, you just do 1 flute, and that's what I do. Are good to go. So that did reduce. Okay, so that's right. All right, this is going to be comment spot drilling. All right, and then we get in here and we can go to cut parameters, and this is going to be drill contour. This is a G81 cycle, so that's what we're going to live with. Dwell is going to leave it. Nothing needed there. If you had G81 on or other parameters, these would, you know, turn on. Tool axis control, we're not going to worry about. Whole segments, not going to worry about. Linking parameters, we are going to worry about. So we will turn our clearance plane on only at the start and end of operation. We'll change it to 2 inches, and we'll turn absolute on for all of these. I think that'll help immensely. 0.1 for retract. Top of stock 0 is correct. The depth, let's go into here and use this little calculator. And we want a finished diameter. We're going to go to 0.3. That's fine. The flat on most of these 3/8 spot drills is going to be a 1/16 of an inch roughly, so that's fine. And then this will automatically calculate how deep we need to go to get this diameter established on the workpiece during spot drilling or countersinking. We're going to use that too. We're going to overwrite depth and hit green check. There it is. Okay. Tip comp we're not going to use for this. Everything else should be okay. Planes, make sure it's all part for this one. Coolant on. Hit green check, and there's our spot drill. Okay, so now what we can do is go to backplot and watch this run. Okay, And we are using, this is a 90-degree spot drill. That's okay, but let's change that because I prefer a 118-degree spot drill. So let's go to parameters. We could access it here through spot drill. I'll show you that now. We could just click the tool. And then I'm going to go to tip angle 118 and go to finish and then regenerate. The only thing I want to check, go to my parameters and go to my linking parameters and make sure my depth is going to have to be updated. Let's just double check that. The finish number is 0.3, flatten the tip 0.060, green check. So it's a little different because the angle changed. So we'll hit apply, green check, and we're good. So I'm going to you go to backplot and hit the S key and take a look. And that'll be fine for what we're doing. We're not going to overcut it. That's fine. Looks good. Okay, good. So the spot drilling is good. All right, we'll turn that off. And now what we can do is we can actually take care of drilling these, and they're going to be drilled separately. And the first hole we'll take care of is going to be this 5/16 tap drill for 3/8/16 tap. So let's double check the geometry here. We'll right click and we'll go to Analyze Entity Properties, select that arc, and we should have a arc or a circle of diameter of 3125. We do. So now let's get in here and do a new drill operation. Let's select the surface of the countersink, which is fine. It'll give us a center point, green check. Go to Tool, select Library Tool. Okay, make sure the filter's on. Filter, drill, 5/16, green check, green check. Speeds and feeds look okay. I would actually, my mistake, bear with me, I did not click on it, so double click and there it is. I double click on this tool again, and I would make sure that number of flutes, that is okay. Alright, we'll go to finish. The speeds and feeds look okay. I wouldn't worry about that. We are running conservative, so we'll leave that alone. Alright, even if we go to the 3/8 spot drill, the drill is getting smaller. It's a drill. The speeds and feeds are fine. I'm not worried about that for what we're doing. Okay, I will show you later on how to change the speeds and feeds to a different material after you already did it. We are assuming this part is 6061 aluminum. When we get into the shop, depending on what we have, that may not be true, so I'll show you how to tweak that. For right now, that's fine. Okay, this will be 0.3125, or let's just go 5/16 drill. Alright, so that works. Go to cut parameters, and let's go to pec drill. Let's go to a pec depth of, let's say, 0.2. Alright, and that'll be the G83 cycle. Alright, skip everything else, go to linking parameters. We're going to go to a depth, click that box, select the bottom of the workpiece, and everything else is okay except for top of stock should really be 0, so you can either type in a 0. That's deriving from the geometry we selected, so we'll leave 0 there. Everything else is okay. We'll get into tip compensation, turn that on, and that automatically calculates the breakthrough. So what we're doing is we're going right to the tip of the drill with the 1/2 inch. That obviously is not right. We need to break through probably 20 thou is good. This automatically adds length to the G83 cycle to make sure the drill goes all the way through at diameter. Everything else should be okay. Coolant should already be on. Plane should be good. Everything is good. We'll hit green check and we're good to go with that operation. We can go to backplot and hit play. Alright, and watch what happens. So you see it pec drilling in. Okay? It looks good. Okay? So, now what we need to do is tap that hole. Let's just take care of it now because these are going to be different sizes anyway. So what I want to do is I'm going to right click, copy, right click, paste. Okay? And now we have the same operation twice. What I'm going to do is I'm going to change the tools up and change the can cycle. So I'm going to go to parameters. I'm going to go up to tool, select library tool, go to the filter, turn the drill off, and then I'm going to go to taps, right hand. I'm going to go to ignore the diameter, go to green check, and then I'm going to go through the list. I'm going to find 3/8/16, which should be this one. Okay, right there. Green check. Okay, now when tapping, I'm going to use specific RPM for this. But before we get into editing these for this tap, I'm going to go into cut parameters. I'm going to change it to rigid tapping cycle, not tap. Rigid tapping cycle, very important. Once that's done, I'm going to go to tool, Then we'll go to spindle speed. I'm just going to go 100 RPM and click somewhere on the screen, and you'll see it automatically updates. And then you could back reference, to make sure that's right. So again, it's going to be 100 divided by 16, which is 6.25, which is correct. So that's good to go. All right. Everything else is going to be okay. The only thing we're going to have to watch is the depth, because depending on what kind of tap you have, that might not be enough. So we'll leave this for now, and we'll see what happens. Depending if you have a gun tap or what the lead-in is on the tap. We're just using a Mastercam default specs on that. So for right now, it's okay. Let's just leave it. Green check. There's our tapping cycle. So if we run it in backplot, there it is. Okay, and we'll leave that alone for now. Again, not knowing what exact tap we're using, that is fine. Okay, so now we have that hole is complete. What I'm going to do is start minimizing these. And now we can get into this hole here. So I'll let you catch up, get through the spot drilling of these 3 holes, get this hole drilled and tapped. I'll pause quickly. We'll take care of drilling this hole, drilling and tapping this hole, and then countersinking all 3 of them. Okay, so let's take care of this hole. So we know what drill to pick. Let's get in here, right click, analyze entity properties, select this hole diameter, and we're looking for a 266 drill or something close to that. So let's get into a drill operation. We'll select this geometry, green check. We'll go to tool, library here, select library tool. We'll go to the filter, taps off, drills on. Equal, let's see, 0.266, if there is a drill equal to that. There is, letter H, so that's good. We'll hit, double click on that. So there's our letter H drill. We look good there. Speeds and feeds look okay. This is going to be 0.266 drill hole, something like that. And then we can go back into linking parameters. Everything's going to be okay. Depth will be -1/2 an inch. Top of stock is there. Tip compensation we can leave on. Everything else should be okay. I always check the planes. And we'll go to make sure we double check our cup parameters, turn that back to pec drill, and we'll hit green check. So that now is complete. And now we can do one more, and we're going to do the tap drill size for this hole. Now, I am anticipating that we're going to have an issue here, and I want this to happen because I want us to see what collision detection does. Only a little bit, because this is real common to have an issue here. Or situations like this where you're going to hit the fixturing potentially. Now again, this is aluminum, so it's sort of irrelevant. But for right now, I mean, these jaws are aluminum, so you could drill right into that and be good. But what I want to do is make sure that we get a collision, or just show you that. So what I want to do is go to drill operation. We'll select here, green check. First thing we need to do is we need to know what drill to actually pick. So let's just X out of there. I'm not going to keep this operation. Before I do that, I go to analyze entity properties, see what diameter this is, and it looks like we're looking for a 368 drill. So drill, select, green check, and tool, select library tool, filter, and it should be 0.368. Green check. Letter U drill, good. Double click. There it is. Speeds and feeds look okay. Cup parameters, pec drill's fine. Linking parameters, -0.5. Top of stock, 0. They look okay. Tip compensation on. Everything else should be okay. Green check. So there it is. Okay. And our drill, let's take a look. And I'll show you the actual verification here in a minute. We'll actually verify this hole separately. So everything actually looks like that barely hits. So let's see how this verifies. So right now, we need to take care of our stock, and I didn't do the stock first because I want to show you what happens when we don't set up our stock correctly. Right now, if we hit verify, take a look what our stock looks like. Oh, looks like the vice jaws. Looks like our previous operation. It's no good. That's not accurate. So what we need to do is create a stock model, and we had a stock model. It's not a stock model as far as our levels. We're going to use that in a minute, but what I'm going to do is go up with this red cursor to the top of this program, or the toolpath group underneath part. I'm going to go over to stock model. Alright, and what we're going to do is create a stock model. And the stock model is just something we reference as other stocks, as these stock models can be based on material you cut. so you can see the results of your cutting and then apply that to other tool paths for referencing. This is just something, other ways to create stock mid-program. There's only one initial property stock. This is the other stocks in your program, and you don't even really need the first stock method of setup we did. You don't really need that. You could use this the whole time. That's debatable. Everybody has their own method. So right now what I'm going to do is I'm going to go to, first thing I like to do with stock models is I always have them on top. I start with the stock plane on top. Then I'm going to go to model, go to the arrow, go to levels, turn my stock model on, turn my model off, select this model. Okay, I just clicked it 3 times and select the whole thing. Hit end selection. So it should be good there. Okay, the color, a lot of times people pick these like, gray. I'm going to end up going with something that's red, and actually more like a pink color. And then the material, I'm going to turn it on to glass, and that'll help us later on. There are no source operations because this is just the initial stock for the part. We can hit green check, and there's our stock model. Okay, now a stock model is another toolpath, so you can turn it on or off with these squiggly lines. Okay, which is kind of handy because in levels we can turn off our stock model, turn on our model, and then we go back to toolpaths and we can re-access our stock model at any time. Okay, so how do we fix verify? Okay, so in our simulator settings, we're going to select not stock setup, but we're going to select stock model 1, which is fine. Okay, then, because that's what we left at the default name. Then in fixtures, I'm also going to have the jaws as the fixture. Okay, and hit green check. Now, one other thing we might have an issue with, it might think it's crashing when tapping. So we'll keep an eye on it and see what happens, and we can go through fixing that. So we can select all of these, and actually that was a mistake on my part because I selected these 2 here, so this selects everything. What I'm going to do is just select the part and make sure these are off, minimize it, we're good to go. So by selecting the top of the toolpath group, you select everything below it. And that's why we chain it or use this tree that way. So this tree being here is very important. Make sure when you make new toolpath group that you want to select all together, that you start right click, new, groups, new toolpath group, and that these lines make sense, because it could be just another root for under this tree here, and that's no good. So we'll select part, let's go to verify, and let's see if that updated. So that looks better. Okay, the only issue we have is we have an extra jaw out in space, which we will work with in a minute. Okay, so let's just go here and stop conditions, op, and collision. So leave those on. Verify is good. One thing we'll go is file options, and make sure that collision checking is with fixture, machine, stock, not the workpiece. Make sure that's not selected, because then the tap will think it's crashing. So make sure that's off. Okay. So we're good there. And let's slow it down. Let's hit play. So here's our spot drill. Here's our drilling op. There's the tapping up. Now I know it pecks, but it doesn't. You'll see the code. It's okay. And then we'll peck drill, and then we'll drill this one. A collision occurred. So there is our issue. Okay, so that's how collision checking works in verify. So it says, okay, you hit something. You hit something based on the parameters that you gave it. Okay, so what we need to now is X out of here. Okay, and let's take a look at what we're going to do to finish this. So I'll pause here. Take a look at verify, make sure you have your simulator settings set up correctly, and then we'll go through and what we're going to do to fix this. Okay, so just to reference that vice jaw we had out in space, all I did was regenerate the operations by selecting part and hitting regenerate all operations, which is right here. Then I saved it and it went away. Can't explain it. Things do happen. If that happens to you, let me know. I'm anxious to see if that's something that happens, if it was in my process, but it went away for me without me having to change anything, so just something to keep in mind. What we need to do now is we need to go back and we need to shift this part or shift this jaw away by adding material to the face of the jaw here. Okay, and then updating the toolpath to reference that, so when we cut them it makes sense. So what I want to do is I'm going to go to levels, and actually you don't have to do that, you can just go to fixture, and fixture goes to the work coordinate system we're working with, the gnomon we're working with, and the levels. Notice that the stock model's still on. So there we are, we're good there. Okay, what we can do now, remember, we just can't shift it and move it. We were set up in a way that these were 2 inches apart. Okay, so a couple different ways to do this. Okay, you can actually, you know, draw a line, offset it over, then snap to it. That's fine. Okay, you can do the math and back from it. It's 2 inches from here to here. We just have to take, you know, and then move it over the amount to get 2 inches in here. That's fine too. One other way we can do this, okay, is actually just move it, then move it back, which is fine too. So we'll go through dynamic translate, dynamic, select these two, end selection, select this corner, select the y-axis, and select the corner of the other jaw. Be very accurate with this. Okay, so that's good. Hit apply. Okay, I'm going to select these two again and hit end selection. Okay, I'm then going to select the corner again, select the Y, and bring it back minus 2.0. Enter. Then I can go green check. So I can clear colors now, and then quickly right-click, analyze distance, select this line to here, and it is 2 inches away. Because remember, we're going to clamp on a 1, 2, 3 block in there. Now we're back. If we turn our fixture on, we're back where this makes sense. Okay, so what we need to do is update this model. So we really don't have to update the model itself. We will, because it will look different on. You want to make it as real as possible. That really helps. And if you don't, you can fake it out. You can draw geometry, and then, oh, it's not there at the machine. That doesn't help with our planning, and we wouldn't have caught that, you know, little collision there and things like that. So it does help to be accurate. So for right now, okay, I am going to go to levels, and I am going to turn on the fixture cut wireframe, because I am going to reference this line. This line is going to move. But for now, on this model, I'm going to go to model prep, and I'm going to go to push pull. Okay, I'm going to select this boss, and I'm going to move it. Okay, that's 200 thousandths. I'm going to move it 0.150. Enter. Enter. So that shifted that jaw in, and that'll work for us. We're going to move it, and we'll hit green check. Now, the only problem is our little line that we apply geometry for is in there. Okay, let's leave it for now. What I want to do is make sure that my fixture cut wireframe is on. I want to go to wireframe, curve on one edge, select that line, and hit green check. Now we have a new line. And go back into toolpaths. The contour pass that cuts that step is op2, step in jaw. We can go to geometry, and now this is how you edit your chains. You can, there's chain 1, there's chain 2. So we can right click and delete chain 2. We can then right click and add a chain, this new chain. Hit green check. Green check, regenerate the operation. So now that updated. But I do want to get rid of that line. You don't have to, okay? But to do that, I will go to levels. I will turn the jaws off, select this line and hit delete. Turn the jaws back on. And then what I want to do is check this program, okay? And I want to check it in backplot because I want to see the jaws. So I want to go both of these, and actually not even really both of them, just the second contour will be fine. We'll go here, and we'll hit play. So this side should be fine. That looks good. And now this side looks good. So now we just modified the program to cut the jaws and the model, or you know, the actual, I guess you want to say, tool design of the jaws. So now we go to fixture and turn both of them off. We can go to levels. We could do this individually, or we just go to part. Okay, so now we're ready to bring our jaw back in. So then we can get back in here and go to transform, dynamic, select the jaws and selection, select the corner, the y-axis only, and bring it to the edge of the workpiece. Okay, we'll hit green check, clear colors, and now we should not have an issue with crashing. It looks like we have enough space, but let's run it anyway. So we'll go to toolpaths, okay, we'll go to the part, we'll minimize the fixture, we'll go into verify, alright, right click, fit, and then we can go isometric, or we can go isometric reverse, which I prefer for having a work coordinate system set up the way we do. Then we hit play. And you'll see the colors changing. That's because color loop was on. That's what that does. Alright, spot drill, drill, tap, drill, and drill. No collision. Okay? So we just fixed that collision. So allow you some time to do that, and then we'll come back, we'll tap the holes, we'll countersink, and then we'll get into other hole operations. They're actually milling, but they're in the hole toolpaths, hole making toolpaths area. Okay, so let's get in here and let's go to levels and let's turn off our stock model, and we'll go back into toolpaths. And we're good to go here. When we turn it on, we'll see all our ops, but we don't need that for now. What we need to do now is use our red cursor and bring it down to the last op right at the end here. And now we can get into actually tapping this last hole that we had to update the fixturing to achieve. Otherwise, we had a little bit of a collision. So what I want to do is go to drill. This is kind of rinse and repeat here. So we'll select this geometry, green check. And this has already been tapped. So we can go in here, tool, select library tool, and filter. Go to the right hand taps, equal, and this is 7/16 14. I will double check that. Yep, 7/16 14. Get in here, select that tap, green check, and then what we can do is go to cut parameters, go to rigid tapping cycle, go back to the tool, update the spindle speed to 100, click on the screen, and then we'll do our math. It's going to be 100 divided by 14 equals 7.142. Yep, that's correct, very accurate, excellent. That's what we want. Comment is going to be 7/16 tap, all right? And then let's see what else we got here. It's good there. We're going to get into our linking parameters. The depth is going to be down to 1/2 inch. Top of stock is 0. These are okay. Tip compensation is fine. We're going to have to tweak this anyway, most likely at the machine. Change the Z minus in the tapping cycle because we don't know what tap we're exactly going to use. If we're using a form tap and we have to change our tap drill size for that, we can tweak that. You know, if it's a very long lead in to get full threads all the way through, you have to you have to be accurate with how the tool was designed for the software to realize it. We're just using the default tool, so for right now this is fine. I do want to double check my planes. That is correct. We'll hit green check. So there's a tapped hole. I do want to just check this hole here. So let's just hold control and select the two 7/16 tapped hole features. Verify. And now we'll only verify those two, and it'll save us some time. So we'll go through there. Now, what happened? Okay. Let's take a look. This is the tapped hole. Let's see where this is. So, what we had is if we actually look at the operation, okay, they are mix matched. We did the 7/16 hole first. So, how do we move this around? And also, we should label this. This should be a U drill. It is. So if we hold that, this should be, let's just go 7/16 tap drill, or even just drill. I'll call it U drill too if you want. It's fine. They're a different order. I don't really want that. So how do we change that? Go up, okay, to there. Right click, cut. Right click, paste. I like the cut, copy, paste method of this. You can click and drag and hold, but I prefer I think it's more accurate to do with the copy and paste. That's me. All right. So now we'll select op 8 and 9 and see what happens. It should be doing just those two holes. So it should, if I slow it down, pec drill here, and now it should. You hit play, and it should tap it, and we look good. There's plenty of clearance, so that should be fine. Okay, the overall depth here we'll take a look at when we post the code, but again, I'm not worried about the tap depth for now because I'm not sure what taps are going to be running in the shop at that particular time. And if it's a gun tap with 3 or 4 thread lead in, then we're going to have to account for that. So for right now, that's fine. All right, now what we need to do is get into, we'll turn these two off. Notice how they go kind of gray. And we need to take care of this hole. Now this is a reamed hole. It does have a tight tolerance on it. So it is plus or minus 1. So we could ream it. That's fine. We could do a drilling, drill it 10 thou under, and then ream it. That's fine. There is a ream. You use G81 for reaming. That's fine. But let's work with some other different tool paths just to get some experience here. One of the tool paths I use to mill accurate diameters, depending on the depth of the hole, is going to be helix bore. This is a good helix bore operation as long as you can get chip evacuation. So this is not a very thick part. It shouldn't have a problem. Helix bore is just going to take an end mill and helix all the way in. Okay, using comp the whole time. So what we can do is we can get into here and go to helix bore. Okay, and notice it is a drilling operation. So we'll select the surface of this hole. Okay, that's good. Move this window and hit green check. So now we can go to tool. Let's go to the library tool. This is a 3/8 hole. So that means we need to go and find a tool that will fit in there. And actually, you don't want to use, even 5/6 1/4 inch is going to be ideal. You want the tool to have some clearance to move so that the chips can get out. So we use a flat end mill equal to 0.25. We'll go green check. Select that cutter. Okay. And our speeds and feeds look okay. That's fine. Rapid retract is fine. This is going to be helix bore 0.375 hole, something like that. And then we can get in our cut parameters. We want to change our compensation up to wear. We want to leave nothing on walls and floors for now. All right. We want to start at center, end at center. We want an overlap of 20 thousandths. Okay. Perpendicular entry we can turn on also. That's fine. And the entry arc exit sweep. These two we might change in a minute, but I want to show you what they do first, and then we'll come back and edit it. Roughing and finishing. I'm going to put a rough pitch of 10 thou. Okay, one rough pass. Feed rate at final depth you can reduce to 30%. That's fine. It's not going to be taking much material. It's just cleaning up a little bit because we're not leaving anything to finish. And we're not really necessarily finishing separately. We're just going to helix all the way down, and that'll be it. That'll be fine for what we're doing, just for showing you this tool path. Linking parameters. The depth, we're going to go down to the bottom of the op. Okay, absolute, going to be minus 0.5, and I'm going to go past a little bit, like 510. Top of stock is 0, everything else is absolute. Clearance plane on, 0.1 for retract, and we're going to go 2 inches on clearance. That's good. Arc filtering. We could use this now and do output 3D arc entry motion, but I'm not going to worry about that. We'll cover that later. I don't think this is necessary. Coolant should be on. Let's just take a look at this toolpath. Green check. There it is. The end mill is helixing in. Okay. All right. So let's watch that in backplot. And you'll see the cutter work its way in. Now, take a look at this green lead-in, all right, and let's tweak that around a little bit. So, we'll go to Tool, or I'm sorry, Cut Parameters. Let's change the Entry Arc Exit Sweep to 90. Hit green check, regenerate the operation. See the difference. Okay. Go to Parameters again. Start angle, could be at 90. Let's go 45 degrees. Check, regenerate. See what that does? It moves the angle of start point around. Okay. Perpendicular entry. Turn that off. Green check. Regenerate. See what happens. Okay. So that's not a bad. It'll have enough room to turn the comp on here. You got to start your comp with a linear move and then radius its way in and go. That is a good tool path right there. So lead in, lead out. Okay. I was just tweaking these to show you what they did. So it's sometimes easier to see what it does versus, reading what it's about or listening to me. So there's a helix bore toolpath. They're pretty accurate. If your machine's tight, it'll give you a good hole diameter, and you have the ability to comp it in. So that's just an example there. So that operation is done. And now what we can do is we can work with these, and what we'll do is a little different here. We're going to use what's called circle mill, which is sort of like helix bore. So it's going to ramp in, but then it's going to go to a depth and work its way out. So it's not going to helix all the way in like helix bore. It's a little different type of setup. Okay, so I'm going to pause here, finish your helix bore operation for this hole, and then we'll finish this last hole, and then we'll mill the ends, and this part will be complete. Okay, for this circle mill operation, it would be ideal to pre-drill this. It is always better to pre-drill when possible. It's easier for the end mill to just plunge in, work its way around. End mills don't necessarily like to plunge in or even helix in like we're doing here. But the main purpose of this exercise is to give you some experience with the tool pass in the hole making here in the hole making gallery of the milling gallery here. So we're going to work with circle mill. Okay, and what we're going to do is we're going to circle mill the counter bore, then circle mill this bore, all using that 1/4" cutter from the helix bore. And again, that may not be ideal. You may want to use 2 different cutters, rough and finish. I'm not worried about that for now. These tolerances, this is somewhat tight, so you may want to use a separate cutter for this one. But this one here has a somewhat loose tolerance, so it's up to you on that. I'm just going to use the same cutter because again, I am just worried about the practice here. So if we go to make this, just realize that you will have to hold the tolerances. We are only making one part, so in reality, if you comp this one to size, this one should be in tolerance. So take that for what it is. Just know that instead of roughing and come back and finish with a separate cutter, I'm trying to save some time here and just take care of the main operations here. So knowing that, let's get into circle mill. And I'm just going to select this upper arc right here at 719 thousandths in diameter, green check. We'll take care of this one first. So for tool, we are going to use that 1/4" end mill tool 8. This will be C-bore. Everything looks good here. Cut parameters. I want to use wear comp. I'm going to leave nothing on the walls and floors. Start angle 90 is fine. Now for roughing, we do want to put roughing on. I'm going to use a 25% step over. All right. And helix entry is fine. We'll helix in. All of this stuff should be okay. We'll go default here. Z clearance, I'll go 0.025. That'll save us some time. And I am going to use a plunge angle of 1 degree. We'll take it nice and easy here. All right. If helix fails, skip. Leave that on. That's good. Finishing. We'll go to finishing. And this is where if you wanted to do like rough it, then do it finish pass or a leave amount, the spacing is what you would leave to finish. Okay, you're only going to want to finish at final depth. So if we did want to like rough this out with the helix and then come back in and finish it with the same cutter, we could leave 3/1000ths here. We could also override the speed and feed for a finish pass. Not worried about it. We'll go to final depth. We'll turn the finish check on, 1 finish pass, and the spacing is how much you're leaving to finish. Okay, transitions. Make sure we turn lead in and lead out on. This is critical. This is fine, this is fine, this is fine, and the overlap of about 20/1000ths. And then we'll take a look at that in a minute. The entry arc sweep of 90 will probably be okay. This is a good size area here. If not, we'll tweak that. Depth of cuts, we'll use depth of cuts this time. So max rough step, let's go 50/1000ths. And we have, we'll just leave 1 finish pass. And this is if you want to finish bottom. We don't, we'll just go to 0. Okay, override speeds and feeds. Everything looks good here. Tool axis control we don't need. Hole segments don't need. Linking parameters we do need. Get back into here. Again, kind of redundant. Change all these to absolute for what we're doing. This will just avoid issues later. Change our retract to 0.1. Feed plane to 0.1 is fine. Top of stock is good. Depth, we'll select the bottom. Here. Alright, minus 1/4 inch. That's good. Double check the planes as part. Coolant is going to be on. And then we'll hit green check and see what it comes up with. So, we'll take a look here. Okay, it looks pretty good. You could see our lead in and lead out for the circle mill passes. Okay, so let's take a look at this in backplot just to get an idea what the tool's doing. Okay, so let's take a look here. And we'll get into backplot just as one operation. I will slow it down and hit play, and we'll see what happens. So it's going to helix in, just like helix bore. And then it's going to circle mill out at that depth of cut. Okay? So That's the idea here. You will see the tool come up and move. We could use keep tool down and it would save some time, but it's alright for now. Alright. Working its way down. This is going to be our final pass. And there was a finished pass right in there. Right there. Okay. So, let's go to top view, and I want to show you something with that spacing. So, let's get into backplot again in top view. Let's turn toolpath verify on. Let's turn the holder off and hit play. And we'll let it do one pass. Okay. So if we look here, you'll see the gap. That's our 3 thou gap. If we let this run all the way through, we'll zoom right in. Now the gap is gone. That's spacing. So it's very important to know that, let's say, for whatever reason, we want to get back into finishing, and let's change this to 50,000, or yeah, 50,000, something good size. So regens, backplot it. All right, hit play. See the size of the spacing now? It's 50 thou. So the spacing is how much you want to leave to finish. Okay, so we'll go back to 3 thou. All right, finish was only at final depth. That's fine. All right, and I'm going to put keep tool down on for this one. Green check, regenerate. So we have just did the counter bore on this workpiece. Okay, so now what we can do is we can actually right-click, copy, right-click, paste, and now we can use the same toolpath with different geometry. So I'm going to rename this one as C-bore clearance hole, and I'm going to go into the geometry, but before I do that, I'm going to pick the previous circle milk toolpath and turn it off so I can see what's going on. And then now I know that since this one's off, we'll turn the helix board off too. We know that what I'm looking at is this operation. So I'm going to go to geometry. Okay, I'm going to right-click in here, right-click on this, and I'm going to delete. Then I'm going to come back in and select this hole, 397, green check. Regenerate the operation, and you'll see that, well, our linking parameters aren't correct. Go to parameters. We're going to go into linking parameters. We're going to change our top of stock to right there, and our depth to right there. I'm going to change this to 510 to give it a little extra. Now, you have to remember that some of these, if they're incremental, are based off something else. Since these are all absolute, the feed plane, everything, and retract all come from 0, 0. The problem is the feed plane is going to be feeding up in space. Let's hit green check, and you'll see what I'm meaning. The feed plane's up here. Okay, we could turn that to incremental and get rid of some of these, but for right now, I'm just going to leave it, and we can watch what happens. And overall, it's not terrible. I'll probably leave it for that for now. We'll go to top view. Everything looks good, so I'll probably leave that for now. I don't think it's worth going back in and trying to, get rid of some of these lines. I think it's fine for now. I wouldn't worry about it. It gets the point across what I'm trying to achieve for this lesson. So now, all the holes are machined. The only thing we need to do is go back in and take care of these countersinks. So what I'm going to do is I'm going to pause here. We're going to come back with a 3 different countersink operations because they got 3 different depths. And we will machine these 3, and then we'll come back and we'll do the contour and we'll be done. Alright, so let's take care of the contours. So we'll turn this, or not the contours, I'm sorry, the countersinks. Then we'll do these contour operations last. And so to do that, let's do 3 different holes, okay? So we'll get into here and go to drill. And in drill, I'm just going to start by selecting this geometry, which gives a 425 diameter, which should be good. We'll work with that diameter. That's the outside of the countersink. It's a drill operation. The tool, we're going to select library tool, filter, turn the taps off, and we'll go to countersinks. Let's see what we have here. We should have a 3/4 inch 82 degree countersink. That's what we'll use. Green check. So tool 9 is there. Speeds and feeds look okay. We're good for now. Double check. You gotta make sure. I'm not sure in the shop. Usually we have one flute countersink, so we will update that. That's good. And this will be C-Sync 3/8/16. All right. Cut parameters. I am gonna go just to a drill counter bore. I'm gonna dwell for 0.4. Should work. Okay, that should be 4 seconds if I'm right, but we do want to dwell, so we'll keep an eye on the code and what that looks like. Let's go into here, linking parameters. Now, everything should be good from before, except for top of stock. We're going to want to fix that to 0. The depth. So, in theory, this tool probably has, at least the ones I know in the shop, are about 0. You call them 0 for the tip. There is no flat the way they're touched off. But the finished diameter on this example is going to be 425. So we'll get back into linking parameters and type in 0.425. Overwrite depth, green check. All right, tip comp is off. Everything else should be good. So let's hit green check. Now, let's watch this in backplot. And if we watch it, it should stop at the end without retracting. Okay, and I lied. So we'll come back into here, and what I'm going to do is just hit B for back, and it goes right here. And that's where it stops. And that looks pretty much right. Okay, so the calculation looks good. You just got to make sure that there is no flat on the tool. The ones that we have are sharp. So there's our spec. So that's good. So now what we have to do is go to the rest of these. All right, and what I'm going to do is I'm just going to right click, copy, right click, paste. And I'm going to go to geometry. I'm going to select this geometry. I'm going to get rid of the solid feature one, or just delete that one. So we're just going to 0.47, green check, parameters, and I'm going to go into, just my memory's fresh, it is 487. I'm going to go into linking parameters. I'm going to go to 0.487, overwrite depth, green check, so we should be good there. Everything else is okay, green check. Let's watch this one in backplot. So I'm just going to hit S to skip forward. So there's S, we look good. Oh, S and B will go through this. Okay, so that's good. And then we can copy and paste this again. So I'm going to go just right click, paste. I'm going to get back into here. I'm going to go to geometry, delete this one, and then add this one, 0.51. Okay, parameters. Change this finished diameter, 0.51. Green check. Okay, green check. And we'll watch this one. So S. Okay, looks good. So all of those are countersunk. We could go back in here and deburr these, but we're not going to worry about that for this operation. It should be pretty self-explanatory, so if you want to do that, great. All right, that looks good. So the only thing we need to do now, all right, is relabel these. So let's label this one. So click on it and move. And this is C-Sync for 7/16/14. And this one is C-Sync for lower left clear hole. Something like that. Okay? So now those countersinks are done. So what we can do now is I'm going to hold Control on the keyboard and select all 3 of those and turn the ops off. Now what I want to do is I'm going to do a contour operation to mill this to length. Okay, so I'm going to go into toolpaths, get into here, and I'm going to go to contour. Okay, so now we don't have any wireframe geometry here. We could put it there and work with it, but what I want to do is show you 3D features. So that's why this is what we've been using. Since there's no 2D geometry, this defaulted to the Solids tab up here, which gives you a different selection method window. So what I want to do, okay, you see loop, edges, all these different options. I want to go just to edges, turn loop off right here. So edges only. Select this edge. Okay. Hit end chain. Select this edge. Change direction so that the cutter is climb cutting. Green check. Different way to select geometry using just the 3D model, and we will use those over and over again as we continue all the chaining. That's just both in one module. You'll get used to that as we go. So the tool is going to be our 1/2 inch cutter. This is going to be cut part to length. Okay. Cut parameters. We'll go to where. Everything should be there from the previous contour. Depth cuts we're not going to worry about. Lead in, lead out is fine. We're going to go a depth of -0.5. Top of stock is good. Everything's good there. Planes is good. Coolant should be on. Alright, so everything looks pretty good. So what we'll do is hit green check. And there are our two contours. Okay. So if we watch these in backplot, there's one. There's two. You imagine the cutter's going clockwise, so that looks good. And that's what we want. Okay? So now what we can do is save. And now we can get into verify and watch this run. So I'll select part, make sure all these are checked. I'll go to verify. It'll load up. And I can watch this run. So we'll hit play. Spot drill. Drill. Tap. Drill. Drill. Tap. Helix bore. Circle mill 1. Circle mill 2. Countersink. 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 We'll slow it down here. And mill to length. So now this part's complete. Alright, we have no collisions, nothing happened, everything looks pretty good. Again, if you wanted to deburr these, you could. Two different countersinks, you could deburr all the way around the workpiece. This is what we'll do later on, but we're not going to do that for this example because we're already getting pretty long with this video. So we'll X out of there, and then what we can do is look at our code. So we'll hit G1. Green check. It's going to ask us if we want to post all. No, we just want to post what we have selected. And then we'll hit OK. Save. Yeah, we can replace it. It's fine for now. Because again, I usually save as after this onto my flash drive. Okay, so here's a program. I'll go 2021. And you'll see there's spot drilling, 5/16 drill, 5/16 drill. And it looks like this one we need to update. This is tap drill. This is actually the tap, so we could update that here. So just tap. Okay, so again, you could change that in the program, or you could just change it here. There's our G84 going down. That's good. Okay, 520 is actually pretty close, so that might work depending on what tap you're using. 266 drill. Here's our G83 with the Q value for pecking. There's our G83 for the tap drill. There's our G84 for tapping. Okay. Here's a helix for operation as a helix is in using comp left on diameter offset 8. And it works its way down. There's a lot of code for that. Okay. So one thing I want to point out is take a look here. We're at, 9,000 lines of code, even though it's only 1,000 because it's skipping by tens, if I remember correctly. Notice how it restarts at 10,000. Let's fix that because that can really burn you at the machine if you want to edit. But besides that, before we fix that, you can just see we come through here and you'll eventually get into your circle mill, clearance hole, get into the smaller circle mill. Okay, and then it gets into cut the part to length. Countersinking. Okay. There's our dwell right there. Alright. So everything looks pretty good. Okay. So what we need to do is let's go. I'll pause the video after this so you can get out of here. And what we need to do is get in our control settings and we'll update this N line number just to work out so it doesn't restart at 10,000 every time, which can be a major issue. Okay, so I'm just going to minimize or actually I'm just X out of the Mastercam Code Expert, and then what I'm going to do is I'm just going to clean this up quickly, and then I'm going to go up into Properties, Files, okay. Then I want to go to Edit right underneath Machine Toolpath Copy. So I'm going to hit Edit, and then what we need to do is go into the Control definition, which is this little control icon box here. So select that and let it load. Alright, we need to go to NC Output, and this is where we have our sequences here. So what I want to do is start the sequence at 1, increment by 5s, maximum, add a couple 9s in there. Okay, then hit green check. Alright, yeah, that's fine. Okay, green check. Let it apply. Alright. So I'm going to select all these. I'm going to go back in to look at the code, post the code, and take a look at it. So you do want to skip a little bit. Skip by 5s is fine, because it allows you to insert lines easily into the end numbers. And we could delete the end number. Sometimes you don't need it, but some of these longer programs you want them. It depends on how quick your program is. So now you'll see that we have N1, 6, 11, and it goes by 5s. We could start, you know, N0 if you wanted to, but this is fine. And you'll notice that, all right, we go right up to 25,000, okay, because we're skipping. Okay. So we're good there. You know, obviously it's not going to match 1, 2, 3, 4, 5 because of all this information on top, which is defaulted. This tells you your tool information, H value, D value, what kind of comp it's using, which is really handy, so leave that. But there's a limit here, so sometimes you got to delete some of this, so just keep that in mind. But again, we got rid of the restarts and the numbering. That's how that works. This is ready to go to the machine. We just finish this, 2021, file, save it on a flash drive, and now you're ready to go to the machine. So that's really it. That is this part pretty much worked through. Obviously, you have essentially 2 different programs here, one to do the fixture, one to do the part. Make sure you pay attention to how the tree works, okay, how this is separate. All right, make sure you have your view sheets, the fixture and part, okay, and then follow along and you know, make sure you machine this part. If you have any questions, let me know. All right, and thanks for watching.